Hello everyone, this is lecture 2 of Basic Programming and Modeling for Geoscientists. Remember the last week we have discussed the motivation for such a course. Indeed, in geoscience we deal with different types of data, for example data acquired directly on the field or data acquired in the laboratory or coming from experiments. And we also deal with theory and conceptualization of processes. So all these things need to be merged together. So the data needs to be analyzed, it needs to be modeled, and it needs to be visualized. Same goes for the models. They need to be visualized and analyzed. So most of the applied research activities in geoscience, they require some form of computing. So it's useful to learn the good practice of computing, and the best way of doing this is by giving you practical exercises. So the three main points of BP13 are to get familiar with basic programming, to become able to handle and visualize data, and to receive basic elements of modeling. So today we will start with the first item, which is getting familiar with basic programming. So we will discuss the basic structure of computer today, and we will also discuss about programming languages and data in the computer. Let's start with the architecture of a computer. So this is a very schematic view of what is a computer. The first thing to observe are on the left side what is called input. So that's going to be you interacting at the input level. And what is at the output? It's again you who will be receiving the information from the computer. So you provide some information as input and will receive some information as output. The input unit is the tool that is going to allow you to give instruction to the computer. So an example of input unit is, for example, a keyboard. It could also be, for example, a microphone. So the input unit lets you provide data to the computer from the external environment. What's happening at the input unit level is that the data you provide is going to be converted from the input device to machine language, and it's going to be loaded in the computer. So other types of input devices also include a mouse or the joystick. A second unit of interest is the storage unit. And in the computer there are basically two types of storage. One is called the primary storage, and the second one is simply called the secondary storage. The primary storage, or the main memory, is the memory which is directly accessed by the processor. It's basically what we call the RAM, random access memory. This memory is directly accessible by the processor. In fact, the RAM, you see examples of RAMs here. The RAMs are plugged onto the motherboard together with the processor. They are next to each other physically. The primary storage is small relatively to the secondary storage, but the access to this memory is very fast. So when the processor needs to access information from the RAM, it can be done very efficiently. The second type of storage unit, the secondary storage, is basically what is the permanent storage. The permanent storage, for example, a hard drive, is physically away from the processor. It's still inside the computer, but it's not directly plugged to the processor. So we say this memory is remote. The data from the hard drive needs to be transferred to the RAM before the processor can use it. So the secondary data is usually very large. You can store a lot of data on nowadays computers. With regard to the size of the primary storage, it's much bigger. But the access to the memory stored on hard drive is typically much slower than the accessing of data stored on the primary storage. At the core of the computer is the central processing unit, CPU. So the CPU contains basically two units. One is the arithmetic logic unit, ALU, plus the control unit. Altogether, this forms the CPU, the central processing unit. So the ALU performs operations. It's basically acting to do additions, subtractions, multiplications, divisions, all those types of arithmetic operations. The ALU, it gets the information from the RAM, the primary memory. And it receives the order from the control unit. It can then execute the instruction. The results can then be stored or directly sent to the output. So the control unit right there is basically the master, because that's the unit that controls the transfer, or that dictates which operation the processor should do. So it controls the transfer of data across all the units of the computer. Right at the output is the output unit. It's used to render the computing results, and it's making basically all the results of computing accessible to the external environment, which is basically you. So the output unit reaches out output device, for example, the screen. You can recognize the famous blue screen here when the computing has been unsuccessful. But it's not only screens. Output device can also be speakers or printers, for example. Luckily, in BP13, we are aiming at having successful results. So that's another type of output. And that's the result of a simulation of wave propagation. It's something we are going to code together at the end of the lecture. So this is a visualization now of a computer simulation of a numerical model that you're going to have to do as an exercise later in the lecture. So another unit which is becoming more and more important in computers is the GPU. So the GPU is a graphical processing unit. It's used to post-process results and send them to the graphical output. So it's like an additional independent processor, and the conventional use of GPUs is to boost your computer for gaming. So I bet a lot of you have very powerful GPUs that they may use to play whatever, Minecraft or these kind of games. And nowadays, the GPUs are not only used for gaming, but they are more and more used for computer simulations. So that's another example of a computer simulation. Here it's a multi-phase simulation, and what you're going to see is basically a fluid that will be extracted from a source region into a rock reservoir. So you see the formation of chimneys. These are porosity waves that are being extracted from a source region and rise towards the surface of the Earth. And this is a simulation that has been computed using GPUs. You can have a look at this link if you're curious about that. So that's basically the end of the first part of this lecture. During this video, you learned about the internal structure of the computer, from the input unit to the output unit, the storage units, and the CPU. What's important to remember is that you interact with the computer. You provide input and you will receive output. Also, the computer will achieve tasks for you. In fact, it will do arithmetic operations, and practically speaking, it can run a video game, which is pretty cool. And another cool type of activity is to run computer simulations. So thanks a lot for your attention.